Welcome back. So today we're going to be working on 7.5. You're actually going to need two different pages today. One of them is your doodle notes. It looks like this at the top. We're going to be working on trapezoids. The other one is the properties. And it looks like this. We have properties for trapezoids and kites. We're going to be starting with the doodle notes. So if you want to go ahead and take those out first. We're working with the trapezoid to begin with here. So a trapezoid has at least one pair of parallel sides. Okay, so this is similar to what we've been talking about with our other quadrilaterals, but this time it says at least one pair of parallel sides. So that's really important because that means we could have more. We could have two pairs of parallel sides, which would make it a parallelogram, but if we have just one, then we're at the trapezoid. Okay, so we're going to go ahead and mark our parallel sides here. Just keep in mind that this says at least, not exactly. So we could have more. Okay. All right. So then other things on here, when we're talking about a trapezoid, we have what's called a base, and we actually have two of those. So the two sides that are parallel to each other, we refer to those as a base. And then the two sides that are not parallel, we refer to those as legs. So we have two legs here. So it's similar to when we're talking about a triangle. We have a base, we have legs. So then when we talk about different types of trapezoids, we have two different types, an isosceles and a right. Again, I want you to think about when we talked about a triangle, what did those words mean? So if we have an isosceles trapezoid, I want you to think of isosceles triangle. Well, if it's isosceles, that means that we have two legs that are congruent. So it's going to be the same thing here for our isosceles trapezoid. So we're going to have our trapezoid with our two legs being congruent to each other. So we're going to mark these as parallel. So those are our bases. And then the two legs are congruent. Okay. Other things about an isosceles is we have what's called base angles. So similar to our isosceles triangle, those are the ones on the ends of the base. So those two angles are going to be congruent. Same thing down here with this base. The two on the ends are going to be congruent to each other. Okay. Next one we have is a right trapezoid. So if you think about a right triangle, it means it has a right angle in it. So a right trapezoid also has a right angle in it. Excuse me. It actually has two right angles. So we're going to go ahead and mark those. And then our two bases here. So a right trapezoid, we have the two right angles next to those two parallel sides. Okay. All right, so that is all for the doodle notes for now. We will come back to these once we're finished with the theorems, and we're going to be finishing up the triads that are over here on the side. And then we have some classifieds on the back side that we're going to be completing as well. So don't get rid of this page. We're just going to do a few other things before we finish that up. Okay, so we're going to come over here to our properties of trapezoids and kites. And we're going to go ahead and fill in some different information there with our theorem. So we're going to start on the left-hand side with our trapezoid. So we have what's called the trapezoid mid-segment theorem. So this piece here, MN, is what's called a mid-segment. Okay, so the mid-segment of a trapezoid is parallel to each base. Okay, so you'll notice it's parallel to each base, and its length is half the sum of the lengths of the bases. Okay, so what that last piece means, we have an equation down here. The length of MN equals AB plus DC times 1/2. Another way that you can write that is MN equals AB plus CD divided by 2. Essentially, we're taking the average between our two bases to find the midsegment. Okay, this is going to become really important when we start talking about area and volume, because we use the length of that midsegment in order to find area and volume when we're dealing with trapezoids. Okay, all right, so we're going to keep moving with our trapezoids. So we're going to move over here to the right. So all three of these actually deal with the isosceles trapezoid. So they're very specific to the isosceles. Okay, so the first one that we have, if a trapezoid is isosceles, then each pair of base angles is congruent. Okay, and we talked about that just a little bit on the doodle notes. We were looking at these angles here. So we have A and D are congruent. And then we also have angles B and C as congruent. Okay? All right, so the next one we have is a converse. So remember, the converse means we're flipping the if and the then. So this time we don't know that it's isosceles. We're going to start out with if a trapezoid has a pair of congruent base angles, then it is isosceles. Okay, so if we know that these base angles are congruent to each other, then we can say, yes, this trapezoid is isosceles. All right, let's move on to the next one then with our isosceles. This one is diagonals. So dealing with our diagonals, it says a trapezoid is isosceles if and only if its diagonals are congruent. Okay, the diagonals are congruent to each other. So I'm going to circle this over here. So we have AC is congruent to BD. Okay, so we're looking at this one and this one. You can also highlight those if you would like. Okay, so that's what we have in regards to our trapezoid. So we'll go ahead and move over to the left again, and we're going to look at the kite. Okay, so I do want to have you add a little bit down here to the bottom. So a kite, we have two pairs of consecutive sides are congruent. Okay, so a picture that will go with that. So we have the consecutive sides are congruent here. All right, so that is our kite. So it kind of gives you a little bit of an idea of where we're starting from here. And you'll notice that that's marked in all of these pictures as well. So then the next piece, we have the kite diagonals theorem. So it says that kite diagonals, if a quadrilateral is a kite, then its diagonals are perpendicular. Perpendicular. And we're going to circle that 90-degree angle there. So if a quadrilateral is a kite, then we're going to have perpendicular diagonals. All right, the next one that we have here is looking at opposite angles. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So that's going to be this angle C and A. Okay, so those angles that separate the congruent ones, the congruent pairs, those are the ones that are going to be congruent to each other. Okay, all right. So now that we have all of that for our quadrilaterals, we are going to go back to the doodle notes, and we are going to find some missing angles here. Okay, so that's the first part. We're going to find each missing angle measure. So this one tells us it's a parallelogram. Since it is a parallelogram, we know that consecutive angles are supplementary. So that means if this one is 90, this one also has to be 90 because they have to add up to 180. Same thing applies here. If this one is 90, this one also has to be 90 because they have to add up to 180. Other things that we know since it's a parallelogram is that our opposite angles are congruent. So if this one's 90, this corner also has to be 90. Okay, so just a couple ways to be able to find those missing pieces. Isosceles trapezoid, we talked about that one today. And so we said with this one, if it's an isosceles trapezoid, then we have some base angles that are going to be congruent. So that means if this one is 50, this one also has to be 50 because base angles are congruent. We also know if we have parallel lines cut by a transversal, that our consecutive interior angles have to be supplementary. So that means we're going to take 180 minus the 50, which would give us 130 degrees. And then the same thing goes over here. Base angles are congruent, so that's also 130 degrees. Okay. All right, so the next one we have is a parallelogram again. So thinking about what we know about parallelograms, we set up here consecutive angles are supplementary, so that means this one plus this one has to equal 180. So we have 4x plus our x plus 5 equals 180. Combine our like terms, we get 5x plus 5 equals 180. Subtracting our 5, 5x equals 175. So that gives us x equals 35. We're going to plug that back in over here because we want to know the angle measures, each angle's measure. So 35 times 4 would give us 140. Over here we have 35 plus 5, which gives us 40 degrees. And then we know opposite angles are congruent, so this one's also 140, and then this one is also 40. Okay, great job with those. We're going to go ahead and turn the page over here, and we're going to classify some of these shapes. So for this one, it says we're going to write all the classifications. So starting at the top, quadrilateral. Is this a quadrilateral? 1, 2, 3, 4 sides? Yes, this is a quadrilateral. And I'm just going to write quad. Next category would be our trapezoid that had one pair of parallel sides. Does this have one pair of parallel sides? No. So we can't go with trapezoid. The other one that we had was a kite that had consecutive angles being congruent. We don't know anything about the lengths of them. So the only thing we can say for this one is that it is a quadrilateral. All right, moving on to the next one here. We're going to start with deciding if it is a quadrilateral, 1, 2, 3, 4 sides. So yes, this is a quadrilateral. Next is a trapezoid. Do we have at least one pair of parallel sides here? Well, if this one's 90 degrees, these are all congruent to each other. We're going to say that yes, it does, because we're going to actually say it has two pairs of parallel sides. So we're going to go trapezoid and parallelogram. It has right angles and congruent sides, so this is actually going to be a square. But in order for it to be a square, it also has to be a rectangle and a rhombus, which is where the right angle and the congruent sides comes in. And then we can say square. So we have all of those listed for this one. The next one that we have, it has 4 sides. So we're going to mark quadrilateral here. Next, trapezoid. Do we have at least one pair of parallel sides? Yes. So this is a trapezoid. Parallelogram has 2 pairs of parallel sides. I have 1 set, 2 sets. So this is a parallelogram. Next is rectangle. Do we have right angles? I don't see any right angles there, so I can't say rectangle. Next one is rhombus. Do we have congruent sides? Yes, we have congruent sides, so we can say rhombus. And since we said no to rectangle, it cannot be a square. So we're just going to have 4 for that one. Okay, the last ones that we're going to classify are down here in the bottom left. This time we're just doing the most specific. Okay, so looking at this shape, going through the same process, it has 4 sides, so we're looking at quadrilateral. I have 2 pairs of parallel sides, so I can go on down to the parallelogram. So it is a trapezoid, it is a parallelogram. Moving on to rectangle, do we have right angles? No, we do not have right angles. Do we have congruent sides? I do not see that it tells us that we have congruent sides, so we can't do rhombus either. So that means the most specific that we can get is parallelogram. Okay, for the next one, we're going to start with quadrilateral again. It does have 4 sides. Next is trapezoid. Do we have at least 1 pair of parallel sides? We do. Do we have 2 pairs of parallel sides? No, we do not. So the most specific that we can get here is trapezoid. Okay, all right, that is all that I have for you today. Have a great day. I will see you in class. Bye.